Welcome back, everyone. So, we're on to the next chapter of web application security. We will discuss same origin policies, content security policies, and cross origin resource sharing. So, this prevents injecting malicious JavaScript code, like what we've discussed in the first part, which is the vulnerabilities exist in most web applications. We could use same origin policy, content security policy, cross origin resource sharing. By the way, guys, in the last few chapters of this course, we will have the same metaphor, which is a restaurant metaphor that allow us to understand the full stock development. So think of security origin policy as like house rules, like no outside help in the kitchen. So imagine your restaurant has a strict house rule. Only staff hired and trained in-house can walk into the kitchen and interact with the server. No outsiders allowed, even if they look professional. Now, that might sound secure, or that might sound good in at first hearing, but there might be some issues with that because what if you need some help with another chef from your other uh, restaurant? Then you need to configure or allow those kind of cases. So an SOP basically states the code from one origin must not access from another origin. So here is an example. So here you disregard the first here it was a mistake, but here you go to https www.example.com, but the server are acting or has support on 800, which is HTTP. So the port for HTTP is 80. The local host is 8080, so it's only accessible on localhost, so it's a different port. Not possible due to different hosts here. It's a different host because most websites today requires other domains or other URL. That's why we need some way for the other chef. You can think of that as an other chef to access our restaurant, or like to prepare a meal. Let's say that chef is specialized in some dishes that customers require. So that's SOP. Uh, SOP only affects dynamic loading of resources from JavaScript code. Resources that you embed directly via HTML, on the other hand, can be loaded from other domains, including the following. Let's check this. JavaScript files that are included via the script element, CSS files that are included via link element. So basically, all the things that you are requiring on an HTML needs to be secure. It only allows, like, it's very secure. It doesn't allow for a complex websites or the right way to make your system or restaurant efficient. That's why we have this cross-origin research sharing. So a classic example of this is that suppose you open a developer console in Chrome and try to fetch Gmail inbox data from Facebook. So using JavaScript, you would fetch this, and then result, it will block because the browser will throw a course error because the origin are different. So here in SOP, we only allow the same port protocol and the same host. You can allow a different protocol or host. Um, Coarse origin resourcing. An SOP therefore prevents JavaScript from accessing resource on other domains. So if you have other server, like if you have other domains such as deploying your front end in Netlify and deploying your back end in AWS maybe or Google Cloud, then that's a different domain. That's where the course origin resource sharing. So here's the code for this. Um, Basically, you will specify access control allow origin in your code. So there are ways to configure that in Express as well. So to configure that in Express, you would need to install it in Node.js, npm install course, and then here is the code. So you create a course, import course, and then a whitelist. You can also enable all websites to be accessible via asterisk. Now let's go back to the characteristics of this type of secure implementation. So if you implement a web service and deploy it under HTTPS API.call sub and want to access a web service from that application, you would do this. Um, Access control allow origin, and then you put the name of the domain. Let's say this api.github.com. So here's an example. Fetch this GitHub, then response with JSON, then data, and then console. So another example is for a static assets on S3. So let's say you want to access your web app via your S3 static website. So you have two web apps. One is static, and then the other is a dynamic. To, enab- to enable access from your front end, you configure your S3 bucket course policy like this. So this is an XML code, guys, as you would notice. Allowed origin. So this is an example of XML. Now, your JavaScript code from my app can fetch data.json from S3. So let's say you have S3 that's written in XML. Then this is how you would allow your JavaScript or dynamic code my app to be accessible on that S3. For this purpose, another way is by uh, allowing everything using asterisk. So you just need to change this as an asterisk. Configure calls for Express. So here's how we configure that. App.use course. So we use app.use that course as a middleware. So middleware is like the sequence on how we process meals in the kitchen. So let's say the priority of your web app is to serve the highest priority customer. Then you would set up your middleware or your waiter your waiter, you would set up your waiter to serve the highest priority customer. Content security policy, CSP. So CSP, the SOP governs the JavaScript code. So it's like combining the benefits of CORS and SOP because this type of security allows you to specify in detail what you would allow. Let's say other chef B is not allowed anymore, but you would allow some ingredients to access the kitchen because the customer are requiring for that. Then you would use content security policy. The SOP governs that JavaScript code running in one domain must not load resources from other domains. However, this rule does not prevent all malicious JavaScript code, such as injected into a website via XSS, from being executed. This scenario is where CSP comes into play. This additional layer of security can, among other things, let you determine exactly which JavaScript code is allowed to run and which is not. So JavaScript code, you can think of that as a combination of ingredients that is allowed to be executed in the kitchen. While cores allow you to relax the security rules defined by the SOP, CSP allows you to further restrict these rules. So let's say the reason why you need the chef B from cores is that chef V has the sequence of ingredients or has a combination of ingredients that the customer likes. Then instead of having the chef go there, you just need the copy of that combination of ingredients for the chef A to implement that. For example, you can specify that a web page generally prohibits the execution of inline JavaScript, that is JavaScript code defined directly within script element rather than in an external file. However, not only the execute, so you can define that in your server, the only way to execute special ingredients is to put an inline in your HTML or on your JavaScript file. So on your HTML for your JavaScript file, remember the JavaScript usually in other file, it's not included in only in one HTML, then you would connect or you would put that JavaScript in one file or in HTML. You can define the rules that should apply to a web page by sending the content security policy header to the client with an HTTP response on the server side. As a value for this header, you pass the rules in form of policy, content security policy, and then definition of the policy. So this is how you would implement that. Here, content security policy, default, SRC, self. Don't mind this arrow, guys. It's not included. Um, Image, SRC. So here's, it means that you would allow all the image and then because you put asterisk and then the media in this domains. So you're basically configuring the security in detail. Several options exist for defining the content security policy header. First, you can configure header directly in HTML code using the meta tag. Second, you carry out the configuration directly on the web server. So you another way of thinking this is that you can define the security in the plate. So in the plate that's allowed to be served to the customer, remember HTML as the plate that is served as to the customer. That plate can be configured to apply the CSP, and it can also be applied in the kitchen by the head chef. Several options for defining configure CSP in HTML. Here, how we configure it in HTML. We use meta http dash equiv 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 equal content security policy content default SRC. So notice we apply that in the HTML. So we can also configure that in Express using Helmet. We install Helmet and then uh, the call of content helmet.content security policy initiates the middleware while the surrounding of app. So remember, middleware is how the waiter or the wait stop process the request of the customer. It provides priority on which would be served first. So here, what we instead of implementing it in the plate, you implement it in the system. So you define before the restaurant uh, open how the waiter would serve the customer. So you're basically defining that on the server. So here we require helmet and then const body parser app that use body parser that you are encoded and then app that use helmet that could and then we put the directives style SRC, font SRC, etc. This code provides static files in the public directory, app.use express.static public, app.descend port error, etc. Now we go to authentication. So authentication, think about this as a different ways for you to authenticate the customer in the restaurant. So authentication is like having bouncer that check the customer's ID before they enter and leave the club. So let's say someone will leave the not club restaurant, the bouncer will check that ID. So as you can see, that could be extreme for optimizing your restaurant because some customer that's not like that hassle. So here's an example for this. By the way, this is the graph for the course. So here, this is the graph for course possible with you. This API.example.com can be accessed using this domain because you allow that in example.com. Here, you can prevent this index.html. So let's say you want to restrict the index.html in your application, and then you can define that to be disabled. So here the authentication graph. First, you request so the customer request and then to the server, and then the server send an unauthorized response asking for username and password. Remember, this is how the login process of website works. So the customer or the server asks for the username and password. Then you enter username and password, and then it check the system or the server if you have the username and password, and then it respond with appropriate response, whether you're valid a customer or not valid customer. On the client side, so basically, of course, another thing about this authentication is that some of your restaurant products or services could be accessed outside the restaurant. Let's say you don't need, like some of that don't need to be uh, some of the users doesn't need to be validated by the bouncer. So let's say your menu is available for anyone to see. So you can post the menu outside the restaurant. So they don't need to enter the web application. That could be accessed outside. So here, after successful authentication, the authorization header, including the credential, is sent to the server with any additional request as long as the client is logged onto the server. So let's say the customer enters the restaurant and has a valid ID. Each request of the customer has a validated idea behind for has a validated idea on it because the customer already entered the server. As long as the customer are, entered in the restaurant, that customer can request or order some food. But uh, if the customer is outside the restaurant, he can't order food. Or if the customer is not validated, he can enter the restaurant. In case of HTTPS, all headers and thus all the credentials are also transmitted in encrypted form. Now, session-based authentication, in contrast to basic authentication where credentials are sent to the server with each request after successful authentication, session-based authentication is based on sessions. So another contrast with session-based authentication and authentication is that authentication requires you to actually check the ID in each order. So imagine a restaurant where they check your ID on each order. That is so annoying, right? So that's why session-based authentication could be implemented. So think of session-based authentication as like a stamping your hand. So once you're in and verified, the restaurant stamps your hand or gives you a wristband, aka session ID. Once the user has logged into the web server using username and password, the server creates a session for the user. This session is uniquely identified by an ID called the session ID, which in turn is sent back to the user by the web server and stored as cookie in the user's browser. As long as the user remains logged onto the web server, the cookie is sent along with each request. The web server can then compare the session ID stored in the cookie with the session information stored on the server side to verify the identity of the user. So these are not the modern restaurant, but it is better than the previous one because in each order, the waiter just checked the stump or the wristband instead of checking the ID every time. However, once the waiter send the request to the server, the kitchen check the wristband if it's validated. So as you can see, the instead of the server focusing on creating meals, the server needs to check the wristband if that is on the computer or on the server side or has been validated by the bouncer already. So it takes a lot of memory because it needs to do that task instead of automating that. So the next part of authentication is token-based authentication with which solve just that. So token-based authentication is like giving you a VIP badge. So it's an advanced way to to serve customer because that badge can just be checked by a sensor detector that automates the validation. So the kitchen trust or the head shop trust that badge or authentication badge, just like a security guard that use Garrett to check your belongings in malls. So in session-based authentication, credentials are not sent with each request after successful authentication, but rather a session ID that the server can use to identify. So uh, session-based authentication is already more secure than, but it has disadvantage, right? Once the user is logged onto the website using a username and password, the web server creates a token which can also contain the entire session information and sends this token to the client. The client in turn stores the token, for example, in the local memory and sends it along with each request to the web server as an authorization header. The web server can then use the token to verify the identity of the client without having to memorize session. So that advanced badge allows the server or the kitchen, right, to not check the computer in the back end each time they each time they process the request. The difference between session-based authentication and token-based is that the user is not stored on the server side in a session, but on the client side. So what happened here is that the badge is like the client. So that badge requires some, work from the client side. So that work from the client side allows the system to not just so let's say you have a badge, right, that has a device that tracking tool. So that badge that the customer have that has device tracking tool allows them to confirm the password or something like that that allows them to allows them to do all the work on the client side. So the kitchen doesn't need to worry about authentication anymore. The client just needs to verify it in each order. Just like logging in on your mobile banking app, you just need to enter the 6 digits in password or the fingerprint, etc. Various standards exist for implementation of tokens. The most common is JWT token. So JWT token is how we scale web applications because it allows to the customer to do all the work instead of us checking the token every time. Now, to summarize, we were able to discuss the common vulnerabilities and different ways to mitigate it depending on our requirements. Now, the the more scalable it is, the most often it's more complex, such as the JW token based authentication, but it is scalable. Now, we can also use session based authentication or basic authentication, but those are may not those are not as scalable. The reason why we would want a scalable is that imagine a restaurant that wants to make money as a business. It needs to scale their restaurant efficiently, and it also needs to optimize the first impression of the customer, and then the marketing, etc. It needs to think about that. That's where the optimizing the performance of web application. So what should be optimized and why? With regard to the optimization of web application or web pages, one factor is particularly crucial, the load time, also page speed. That is the time between calling a web page and displaying the web page in the browser. So remember this, guys, because this load time is the main idea behind optimizing websites. There's a lot of concepts behind that, so stick around. So the first contentful paint, imagine that as like a customer. When a customer walks in, it sees the menu or welcome sign. It's the first visible thing, like the host greeting or the menu showing up. So that's one of the concept. But why do we actually optimize the website? First, it improves the user experience. The load time of a web page has direct impact on the user experience. That is how pleasant users find the website. Basically, the shorter the load time of a website, the better the UX. And then it improves conversion rate. Conversion rate refers to the percentage of users of a website who successfully performed a desired action. So imagine you don't have a good first visible thing or first good first impression, then the customer may not go in to the restaurant. That's why we need to balance this optimization with the security as well. It improves SEO ranking. The load time of a web page affects its search engine optimization ranking. So SEO refers to the optimization of web page in terms of the ranking within the displayed result of search engine like Google. So it determines your ranking when searching in Google Chrome. It improves crawling for engines like Google to deliver search results as they do today. They must process web page in a first step. In this context, the process of crawling is important. Crawling refers to the automated tracking of links and working through web pages. Since the corresponding tools, the crawlers, each work with certain time quotas they spend on crawling, the following applies. The faster the web page of a website are loaded, the faster and more of those web pages the crawler can process and provide for the search engines. So the faster your website uh, or your web application, remember web application contains of multiple pages, the faster is that the load time is, the faster the search engine could search for that specific details in your restaurant. So remember, if you are searching for some information like about health or about technology, let's say your app is about technology, then you would want a specific content of your app to be served. by search engine first. But that wouldn't happen if your load time sucks. Now, how can performance be measured? So now we will discuss load times of web pages. Queuing. Before you call a web page or after you enter the URL, the browser places the request in an internal queue. So if you make a request via URL, it is being put on a queue. DNS lookup. When the browser processes the request from the queue, the browser first sends a request to a DNS server to get the IP address of the web server based on the host name. So on the first video, we discussed this, how the URL is being converted by the domain name system. So it converts the name to the actual IPv4 or IPv6 address. This process is also referred as domain system lookup. Not until the browser has received this information will it make the actual request to the server. Connecting to the server, once the web server to which the client is making the request has been determined, the connection to the web server is established. This connection includes, for example, the TCP handshake or also the initiation of a secure socket layer connection if communication takes place via HTTPS. Sending the HTTP request. When connection to the web server has been established, the concrete HTTP request is sent to the web server. After that, that's the only time that the browser will send the actual HTTP request or the get method, because usually you're getting the specific page or specific part of the web application when you type the URL. Preparing and sending HTTP response. Once the web server has received HTTP request from the client, it prepares the corresponding response. For this purpose, depending on the request, the web server itself might need to make requests to a database, for example, to read file, remember the database. So your app may need to check that database, so that's part of a load time. As well, downloading or processing HTTP requests when the web server has sent the HTTP response to the client must load and prepare the response. Parsing the DOM, if the response is, so the Chrome need to load that. So you need to make sure that you minify the code to be able to be read by Chrome. So it's not that it's not only a matter of making your code or making the application optimized. It's also a matter of talking in a way that would make the Google Chrome process your app efficiently. So think of this like a restaurant again. Uh, Instead of providing the a big plate to a small meal to the customer, you would serve the right size of plate to avoid this oversized, code. Parsing the DOM, if the response is formulated in HTML, the client must parse this code and convert it into the DOM, which described in the seventh chapter of this course. Rendering the web page with the information from the DOM, the browser starts rendering, that is drawing the web page. So as you can see, there's a lot of steps. After it received the HTML, with that information, the browser starts rendering or painting. So it actually paints it bit by bit or pixel by pixel. Other HTTP requests per users, if other users are included in the DOM or the underlying HTTP such as CSS or JavaScript, the browser initiates further HTTP requests to load the server. And then after that, it will request for other dynamic content such as JavaScript or CSS to make the it's like after the waiter serve the the plates, or the the plates, the spoon, and the knife, then it will only serve the food, right? So think of that as the initial serving items of the restaurant. Now, this is the metrics regarding the load time that industry use to measure it. Time to first bite. This metric refers to the period of time between the calling of a web page and the time when the first byte is loaded from the screen. So let's see. Here's the graph of session ID, your request for username and password, ID and cookie. So remember the cookie, guys. It has 4 kilobytes. Now here it has header with tokens. And here is the overview for requesting from client to the server. So navigation start, queue, DNS. So DNS it converted, and then the protocol, and then the request, and then wait. It will wait for the backend, and then the backend will respond, and then it will paint the front end. Here is the first byte. So here, as you can see, there's no content yet. So meaning it's just the first time to byte could be yeah. I mean it shows on the graph here the color change. It's called first paint. This metric refers to the point in which time when the browser has completed the first drawing process. At this point, the DOM, the actual content of the web page, is not yet considered, but for example, information about the background color of a web page. First contentful paint. This metric refers to the point in time when the browser, now taking into account the DOM displays on on the first visible text or image here. First content revealed. First meaningful paint. This metric refers to the time when the browser displays the first meaningful elements. This time marks the point at which the user feels that the web page has fully loaded, even if it actually hasn't yet. Sorry guys for that. Spotify. First meaningful paint here. Some elements or HTML elements are actually showing. Time to interactive. This metric refers to the time when the web page has been completely rendered and is ready for user interaction. Now it's ready. The customer can click OK, submit, etc. depending on the features of your app. Overview of the different metrics here. So this is what happened in 3.0 milliseconds. Usually 3.5 milliseconds for first content, first meaningful uh, content, speed index, first CPU idle, etc. It's so cumulative. Actually, sorry guys. There's an additional metric that has been created by Google, which is largest contentful paint. So largest contentful paint is like a main course is served. The biggest, most important thing the customers wants, like their food, finally arrived. So this metric refers to the time that elapses between the point at which the URL was called and when the largest text or image was rendered. For first input delay, this metric refers to the time that elapses between the point at which the user initiates the first interaction with the web page and when the browser responds to that interaction. It does provide information about the interactivity of the website. So it's like customer calls waiter and gets a response, the time it takes for someone to take their order when they call. So as you can see, guys, there's a nuance as well on how fast the waiter receive that. It's basically optimizing. Now we're not on the security side. It's about like the customer service side. How would you optimize it? Not just considering the security, but also how would you serve the customer fast? Because I think it's on the metaphor itself. Some waiter would not respond as fast as other restaurants. Community layout shifts. This metric refers to the total of all unexpected shifts of the layout and provides information about the visual stability of the web page. So it's like table or chair keeps moving while customer eats. It's annoying. Shifts in layout, like UI jumping around while the user reads or clicks. Which tools are available for measuring performance? So Page Speed Insights. It's an online tool provided by Google that analyzes web pages with regard to core web vitals and generates a corresponding report. So it can be added in as an extension, or you can download it here, pagespeed.web.dev. Results are obtained for both the mobile variant and the so this tools is like a customer feedback for forms, kitchen timers, or cameras in the restaurant that helps you improve the service quality of your web app. Chrome DevTools, in addition to the performance tab, the network tab, and its timing subtab also provide useful information regarding load behavior. So this is page the network tab of Chrome DevTools. The performance tab rather. Here you can see the time in milliseconds. Here's the page speed insights. You can see the as largest contentful paint, first input delay, cumulative layout, first contentful, etc. And then here's another page speed insights that provide advanced way to check it. So here's the Chrome DevTools performance tab, and here's the network tab. Here's the time for network tab. You can see there in time. Lighthouse is an open source tool available as a Chrome plugin that can be accessed via the Chrome toolbar or Lighthouse tab in Chrome DevTools. What's particularly useful about that is that in addition to determining performance metrics, aspects such as accessibility and SEO metrics can also be analyzed. So, where's the Lighthouse? So, I think this is the Lighthouse. So, here Here is the Web Vitals. You would check that. So you can just check the and download Web Vitals. That's an exercise for you guys. Options for optimization. So in the next videos we will discuss this, but it basically tackles the geographical location of the server. The closer the server, the faster the load time. So again, we were able to discuss the ways to secure our websites and to optimize or to improve the service quality of the restaurant because goes hand in hand in web application, guys. You have to balance the security and the feature. So again, guys, thank you for watching and see you in the next video. Peace.